Hey everyone. Thank you for being patient with me as I've got my grading up to date since the county released their grading policy last week. So let's go ahead and get started with some more exponential information. And I'd like to take a minute and compare linear and exponential functions because I think it's going to help you to have a better understanding of both types of functions. So let's get started with a little bit of background. So in middle school, you spend your entire time leading up to and developing this idea of linear relationships. In seventh grade, you're introduced to y equals k times x, and you probably heard the vocabulary term k as the constant of proportionality. That's a big idea that gets developed in seventh grade. You spend a lot of time talking about those proportional relationships. Then in the eighth grade, you're introduced to slope-intercept form, y equals mx plus b, and you start discussing m as slope as opposed to constant of proportionality. And rate of change is another vocabulary term that we use kind of almost interchangeably with slope, even though slope refers to the graph, whereas the rate of change is talking about the real world context. And additionally, in eighth grade, you were introduced for the first time to b as this idea of your initial value or y-intercept on the graph. So it only makes sense that when you start out Math 1, we start out doing these units that further develop the idea of linear relationships. Our first several units were on multi-step equations, which is really just linear relationships, linear inequalities, and systems of equations and inequalities, all linear relationships. So again, it only makes sense that the next step in Math 1 would be to introduce you to the concept of nonlinear mathematical relationships. And one of these nonlinear relationships is exponential functions. And you were very briefly introduced to the idea of exponential functions and their graphs last week. Based on your work, I see that there's still some confusion with exponential functions. So I want to take a lot of time to compare what you've been studying, linear functions, to what you're being introduced to, exponential functions. I think it's going to help develop a better understanding of exponential functions for you. So, what is the difference between linear and exponential functions? Well, a linear function in slope-intercept form is y equals mx plus b. You might have something like y equals 2x plus 0. We don't have to write the 0, but it helps me to know that my y-intercept is 0 and my slope is 2. For an exponential, they take the form y equals a times b to the power of x. And this exponent of x is the reason why it's called an exponential function, just as an aside. You might have an exponential function that looks like this, y equals 1 times 2 to the power of x. We don't have to write the 1, but it helps me to understand that that's my initial value. That's the y-intercept for that function. And when we put these functions on the graph, it's easy to see the difference between the two. Your linear function is obviously straight, and that means that its rate of change remains constant, whereas your exponential function here has curvature to it. And what that means is that your rate of change over time starts out kind of slow, and then it picks up. So it's growing over time. Your rate of change is changing. Okay, whereas for your linear, it remained constant. And what does that look like numerically? Well, on an XY chart, when I have a set of ordered pairs, a linear function, which this is the linear function from the previous slide, is going to have a pattern of adding or subtracting in your y values. So these are my y values. From one y value to the next, there is a pattern. What is that pattern? Adding 2. And it's always a good idea to double check just briefly, quickly, Make sure your x values are going up by 1 every time. Okay, always double check that. That's important. Okay, but again, my linear function, y equals 2x, is increasing by adding 2 every time in the y values. Compare that to your exponential function, y equals 2 to the power of x. What is my pattern in my y values? We need to determine what's called the common ratio. How do we do this? Okay, what you're going to do is take a y value, let's say 2, and divide it by the previous y value to determine your common ratio, which is b in my formula, right? We've got y equals a times b to the power of x. My common ratio, my rate of change, is b. So I'm trying to figure out b. Well, in this case, it's 2. So every time I divide a y value, let's say it's 128, by its previous y value, 64, I should have the same result. And I do. It's 2. So what that is telling me is that my common ratio is 2. So from one y value to the next, I am multiplying by 2 every single time. Okay, so in summary, a linear function is adding or subtracting, and an exponential function is multiplying. That is very important. That needs to be committed to memory. Okay, let's take a look at another example. If we want to determine whether this table represents a linear or exponential function and write the equation to represent that function. So taking it one step further. So the first thing I'm going to do is determine the pattern for the y values. So from one y value to the next, what's happening? From 8 to 4, 4 to 2, 2 to 1, and so on. Okay, so what I want to do is determine that common ratio. Okay, so I take a y value, let's say I choose 4, and I want to divide it by my previous y value, 8. What does that give me? 0.5 or 1/2, however you choose to write it. And I should get the same result no matter which y value I choose. If I choose 1/2, does 0.5 divided by its previous y value, 1, also equal 1/2? Yes, it does. So that means that my pattern is to multiply by 1/2 every time. In other words, 1/2 is my common ratio, b. Okay? So since I'm multiplying, that means that this function is exponential, and I need to figure out what is a, what is b. Well, I've just determined b. b is 1/2. So all I need to know is, what is the value of a? How do I know a? The value of a is when x equals 0. So what you're going to look at your xy chart and look for x equals 0. Okay, so this ordered pair, 0, 1, tells me where my exponential function crosses the y-axis. That's my y-intercept a. So 1. When I put those two numbers in place of the variables a and b, this is the result, which can be simplified just a little bit because 1 times any number is that number. So my final answer is y equals 1/2 to the power of x. And I'm going to erase this for a second because I have a little piece of information I want you to see. This is an example of exponential decay because my common ratio, b, is a fraction. And that just means it's decreasing. over time. Okay, let's look at another example very similar to this one. Let's say an artist has two paintings that he or she's purchased. The value of each painting after X years is Y dollars. And this XY chart represents the first painting. I want to write the equation to represent the value of the function after any number of years. So the first thing I've got to do is identify the pattern in the Y values. What is happening from one Y value to the next? So from 24 to 43, 43 to 62, 62 to 81, I want to know, am I adding, subtracting, or multiplying? So I pick a Y value. Let's say I pick 81. When I divide 81 by its previous Y value of 62, is the result the same as when I divide 62 by its previous Y value, 43? I'm checking to see if those two numbers are the same. So the first one is about 1.3 if I round, and the second one is about 1.4 if I round. So they're not the same. Okay, so I'm not multiplying, which means I'm adding or subtracting. Definitely not subtracting because the values are increasing. In fact, they are increasing by 19 every single time. 43 plus 19, 62. 62 plus 19 is 81. And let's go ahead and complete this XY chart. Let's figure out what goes in these question mark spaces. 81 plus 19 is 100. So my next Y value is 100. How do I figure out a previous Y value? I'm going to take 24 and take away 19 as opposed to add 19 if I'm working backwards. So this value would be 5. All right. So what is the pattern? It is adding every time, 19, every time. So if we're adding, that means my function is linear. So I'm working with y equals mx plus b, and I need to figure out m and b. I've already determined m, it's 19. What is my initial value b? B is when x equals 0. So where does x equal 0? This ordered pair, 0, 5. So that means my y-intercept, b, is 5. And I put them together, substitute them for m and b to create my final equation, y equals 19x plus 5. So the value of the painting is $19 per year plus my $5 original purchase. All right. Here is the second painting that this art collector purchased, and we want to do the same thing, write an equation. So we need to identify the pattern in the y values. So I'm going to pick a y value, 81, and divide it by its previous y value. And I'm going to see if that is the same thing as 27 divided by its previous y value. This is 3. And this is also 3. Since those numbers are the same, that means I have a common ratio here. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I am multiplying every single time. Let's go ahead and finish out the XY chart. If I multiply 81 by 3, the result is 243. If I want to work backwards to determine the value of this question mark, I would divide 3 by 3 as opposed to multiplying, and the result is 1. All right, so what is the type of function I'm working with? If I'm multiplying, then I'm working with an exponential function, and I'm trying to figure out my initial value a and my common ratio b. So B is 3. That's what I'm multiplying by. What is my initial value? A, that's when we have an x value of 0. So that's this ordered pair on the graph, 0, 1. Okay? So put those two numbers in my formula for A and B, and I can simplify that just a little bit, again, because 1 times a number is that number. So my final result is y equals 3 to the power of x. The value of the painting is $3 multiplying by 3 every year. All right, so here's my two paintings and their formulas, their values over time. We can answer a few questions by comparing these values. Which painting was worth more at the time of purchase? Well, the time of purchase is x equals 0. So we're looking at these values here. Painting 1 cost more money up front. It was more for the art collector to purchase that particular painting than it was painting 2. Which painting has an increasing growth value? That would be painting 2. Over time, that value, the rate at which it's increasing, is increasing. Okay? That's one of the characteristics of an exponential, is that over time, this is increasing faster and faster. So after how many years are the paintings the same value? So this y is what we're comparing. And if you'll notice, at year 4, we have the same y value, 81. So after 4 years, both paintings have a value of $81. So far, you have looked at exponential functions and linear functions on the graph to see curved versus linear, or line, straight. And then you have looked at exponentials and linears on XY charts. What is the pattern in those numbers? Adding, subtracting versus multiplying. Now would be a good time to pause if you want to take a brief brain break, and absorb the information thus far, because we're going to continue with more examples. So we've got these two young ladies, Lucy and Jada, started a book club, and the next month they each invited 2 new members. The month after, the new members invite 2 new members of their own. Each month the process is repeated. So I want to know, is it linear or exponential? And then I want to complete my XY chart and write the equation. So several things. The difficulty is increased here because the XY chart, all the Y values are missing. So this number here, Y, is going to represent your, let's see if I can change the color here because it's not showing up on this. We're going to have this be your new members. Okay, so when the club starts out, month 0, how many new members are there? Well, it's just Lucy and Jada, so it's 2. And let's say I look at a little bit of a diagram. This is Lucy and this is Jada. Okay, Lucy is going to invite 2 new people, and so is Jada. How many new members are there? There are 4. Okay. The month after, the new members each invited 2 new members of their own. So this new person invites 2 new people, 2 new people, 2 new people, and so on. So how many people, how many new members are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 new members. Well, I don't want to keep drawing on this diagram. I would prefer to look at or identify the pattern in the y values. So from 2 to 4, 4 to 8, am I adding, subtracting, or multiplying? I am multiplying. In fact, if I divide 8 by 4 and then 4 by 2, it equals the same number, 2. So that means I have a common ratio of 2. So I can make predictions about my next y values by continuing the pattern of multiplying by 2. So I would have 16, 32, and then 64. Okay, so if the pattern's to multiply by 2 every time, is the function linear or exponential? Exponential. So I need to know A, B. B we already determined to be 2. So what is my initial value? Remember, your initial value is the first ordered pair. So 0, 2 is where the exponential function crosses the y-axis. So when I substitute those values into my formula, this is my final equation. Y equals 2 times 2 to the power of x. And just as an aside, when I put this on the graph, the coordinate plane, this is going to be exponential growth because it's going up and up. And this point here is your y-intercept of 0, 2. Okay? So let's see if you can kind of do this one yourself. I will help you get the XY chart started, and then I'm going to let you answer a few questions. So there are 50 bacteria in a dish, and the number of bacteria triples every day. So we are going to start out with the 50 bacteria in the dish, and it triples. 50 tripled is 150. And that tripled is 450. And then 450 tripled, 1,350. And then 4,050 and 12,150. Very big numbers. Lots of bacteria. Okay, so what is my pattern in the y values for every increase in x? Hopefully you determined that we are multiplying by 3 every time. When I divide 150 by 50 and 450 by 150, they equal the same number, 3. So that's my common ratio. I'm multiplying by 3 to get one value to the next, to get from one value to the next. So if I'm multiplying, I have an exponential function. Since it's exponential, I need to determine my initial value and my common ratio. My common ratio is B. I already figured that out. So what is my initial value, A? In this case, it's this ordered pair here, 0, 50. I start out with 50 bacteria in a petri dish. When I substitute these values into my formula, y equals a times b to the power of x, this is my final result. Okay, and this is another exponential growth. The bacteria are increasing and increasing over time. Okay, so let's take a look at another example. You've got a certain type of corn that grows at a rate of 3 inches per week. When the seeds were planted, they were placed 10 inches beneath the ground. And again, is it linear or exponential? We want to finish the XY chart and we want to write the equation. So the first thing I'm going to do for this example is really define my variables. So X is going to be weeks. And I'm going to let Y represent height of the corn. Okay. So if I have it 10 inches beneath the ground, so I dig a hole 10 inches deep and I place the seeds at the bottom, that means they're starting out 10 inches below the ground. And then they are growing at a rate of 3 inches per week. So from 1 week to the next, I am adding 3. So we're still 7 inches below the ground level. And then I'm adding 3. So I'm still 4 inches below the ground after 2 weeks. And then I add 3 again. I'm still 1 inch below the ground after 3 weeks. And then the next week is when the seedlings finally make it above ground. All right. So what is the pattern? We're adding 3 every single time. If we're adding, what type of function is it? Linear. So I need to determine slope-intercept form, my rate, and my y-intercept. My rate, we already figured out, is 3. We're adding 3 every time. So what is my initial value? When I start out, these seedlings are 10 inches below the ground. So that means my initial value is -10. They're 10 inches below the surface. So putting those into my formula, this is my final result. I have a rate of 3 inches per week, started out 10 inches below the ground level. So you kind of give this one a try. I'm going to help you get the XY chart and then ask you a few questions. So exercise biologist Samantha discovered to reduce soreness, people should start bicep curls at 5 pounds, then progress weekly by adding 5 pounds. So start at 5 pounds. So this X is my number of weeks again, and then Y is going to represent my pounds and my weights. So I start at 5 pounds, then progress weekly by adding 5 pounds. So you go ahead and think about what my next Y value is. What is the pattern for the Y values? We're adding 5 every time. So my next Y value would be 10, 15, 20, 25, 30. All right, so that means if I'm adding 5 every time, what type of function do I have? Linear or exponential? Linear. Okay, so that means y equals mx plus b. What's m? What's b? M I just determined. It's 5. What is b? B is this ordered pair 0, 5. That is where the line's going to cross the y-axis. So b has a value of 5. When I substitute those into my equation, that's my final answer. Y equals 5x plus 5. All right. I hope that this helped a little bit. We're going to do some practice with linear versus exponential, and hopefully our understanding has improved.